We are finally ready to start a deeper dive into parallel streams. We've talked extensively about sequential streams up to this point. Now it's time to actually focus on the parallel processing. I've mentioned a few things along the way. We've talked about flat map, for example. We've talked about some of the hazards of parallel streams, but we really haven't looked at it in detail. So let's go ahead and start with that discussion now, which is timely because your next programming assignment, which I'll put out in the next day or two, has parallel streams as the focus. So we'll talk about how aggregate operations and various functional programming features like method references and lambda expressions and functional interfaces and so on can be applied seamlessly in parallel streams, which is one of the nice things about this framework. You don't have to do a whole lot of work usually to go from a sequential stream to a parallel stream. So recall from what we talked about so far, a stream is a pipeline of aggregate operations that are used to process or filter or manipulate or whatever a sequence of elements, which are sometimes known as values or data, which of course are also objects in many cases. And so what we're going to have here is something like this, where we've got a stream, and this was the example that we talked about before from this search stream gang, and similar to the simple search stream gang that we talked about. This one just takes works of Shakespeare and phrases and so on, but same basic idea. So here we're going to have a map where we're going to map phrases, and we're going to look them up in the works of Shakespeare. If we find matches, we're going to get search results with non-null search results lists. If we don't get matches, they're going to be empty. So we filter things out, and then we collect everything up into a list. So you notice how the aggregate operations here, like map and filter and so on, use internal iteration, and everything's pipelined together, connected together, if you will, by the streams framework. And we have these behaviors we pass in to process all the elements in the stream. By default, if you don't do anything to the contrary, if you say .stream, for example, on some collection, then there's a single thread of control, and the whole thing executes sequentially and deterministically in one thread. So everybody runs in one thread of control. Remember, again, the way this works is it looks like it's going left to right, top to bottom, but it's really going top to bottom, left to right. If you change stream to parallel stream, as we see here, then all of a sudden, lots of things change. Most notably, there's multiple threads that are used. And those threads, of course, come out of the common fork join pool, which we talked about extensively at the beginning of the course. Now, I've kind of showed it here like there's groupings of two threads. There's actually every single element here that is going to be pulled through will run in some thread from the common fork join pool in its own task. And that just has to do with the way that lists, or more specifically array lists, splitterator splits things up into atomic-sized elements. If for some odd reason you don't like that, you could change the way the splitterator worked if you wanted to split into a larger group than single elements. But at any rate, we have parallel streams, so now we have a bunch of threads and things will be processed in parallel. And these threads in the common fork join pool will process these different chunks of data in an intentionally non-deterministic way. Remember, we talked earlier about how the common fork join pool, and fork join pools for that matter, don't really give you any control over the order in which the underlying tasks run in the common fork join pool. And that's by design. It's to give more opportunity for optimization at different layers of the stack, the hardware and software stack. You'll also notice that these intermediate operations, like map, filter, and so on, also process everything in parallel. What's cool is that nothing really changed. We didn't have to change anything. We just went from sequential stream to parallel stream. And you'll also notice, as before with a sequential stream, that it's the terminal operation, in this case collect, that's going to trigger all of this intermediate processing in parallel. And it's also, of course, going to take all those chunks that are running in parallel, and it's going to pairwise combine them together into a final reduced result. So the final reduced result here is going to come back as a list, because we have a list of these things. And you'll also notice something else important here. Notice that the parameters that are passed here, like the search for phrase, which is a lambda expression, the not search results is empty, those are stateless. So there's no state that's being used there. The toList, of course, is stateful because it's collecting things into a list, but it occurs at the end. And so, as always, we try to make things as stateless as we possibly can. Can't always do that. but it's a good idea when you can. Just as a simple point of reference of a situation that you're hopefully familiar with by now, where there is actually stateful behavior in the various behaviors. If you look carefully at the image processing application that you're doing, the image crawler application that you're doing for the assignments, it's actually storing the content into an in-memory cache, which of course means that those are stateful. However, we're very careful to use an underlying concurrent hash map, so there's no issues with race conditions or other memory visibility or other types of concurrency hazards. But as much as we can, we like to make these things stateless. In the case of caching, it helps to make them stateful, but it's properly synchronized. Ideally, and it's not always the case, ideally we want to be able to make minuscule changes to go from a stream to a parallel stream. In this particular case, it is a minuscule change because we just changed stream to parallel stream. For sequential stream applications that use flat map, as we've seen, there's slightly less minuscule changes, or slightly more overt changes, but not dramatically. You typically replace things with map multi or map reduce stream concat, and away you go. What's nice about all this stuff is that by and large, we can use the same aggregate operations for both sequential and parallel streams. And you can see here that there's a parallel version that uses exactly the same stuff. If you take a look at the search with sequential streams and search with parallel implementations in the search stream gang example in my live lessons GitHub repository, you'll see that they're really identical except for one uses stream, the other uses parallel stream. If I really wanted to be obsessive compulsive about this, I could actually have factored the code out and had it decide at runtime whether to convert the sequential stream into a parallel stream. That would have made the code even more identical and parameterizable. I chose not to do that for various reasons, but very small changes that are required. As a consequence, and this is a really nice feature of Java Streams with respect to parallelism, you can just treat parallelism as an optimization, and without much effort on your part, you can get parallel processing without changing the programming paradigm much at all, which is really cool. Now, as we said before, be careful when you do this because you have to make sure that you're not accessing unsynchronized shared mutable state or shared mutable data. The easiest way to do that is to have stateless behaviors. If you can't do that, then you need to have something that requires synchronization, like a concurrent hash map or a concurrent linked queue or something along those lines. But as a usual rule of thumb, to be violated only when absolutely necessary, try to have side effect-free stateless behaviors passed as the parameters to these intermediate operations. So that's a quick overview of parallelism in Java parallel streams. You'll see as we go further, there's a lot more that can be said about this stuff, but this is a starting point to segue from the sequential world into the parallel world.